Hello everyone and welcome to day 7 of Advent of Code. Day 7 for me, not for you, because it is currently the 16th and I am a little bit behind. So I've got some catching up to do. So what we've got here is Handy Haversacks, which is kind of a cool name. We are trying to solve some issues in luggage processing. We can look at the following rules here, and we're diving in right away, right? So we've got light red bags contain one bright white bag, two muted yellow bags. Okay, so now let's look for the muted yellow bags, right? Which can contain two shiny gold bags, 9 faded blue bags, right? So we've got bags inside of bags inside of bags inside of bags, which is fun. Right, because now we probably are. I'm assuming that we're going to be doing some kind of recursion problem here with this particular data. So we're going to have a bag inside of another bag inside of another bag, and we're going to try and figure out, okay, how many bags how many different ways can we hold different bags, and things like that. So that might be along the lines of what we're going to be looking at. So we have a shiny gold bag. If I wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? So we've got shiny gold bag, but we can hold, so the bright white bag can hold the shiny gold bag directly, but a muted yellow bag can hold the shiny gold bag plus some other bags. A dark orange bag can hold the bright white bag, which of course can hold the shiny gold bag. And we also have light red bags, which can hold the bright white, which once again holds the shiny gold. So basically, we can try and get at, okay, how many different ways can we hold a shiny gold bag? So what we're going to start off with is we're just going to take this data right here, and we're going to put that into our input right here, okay? And then we're going to start off just by building a function that I'm going to call parse bags here, okay? And we've got some data, and right now we're currently reading the input file. We're splitting on the new line, so we get essentially one relationship, or record, I guess you could say. I'm going to call it a relationship per line, and that's the relationship between the bags. One relationship between for each line. So we call it relationships. Okay, so what we're going to end up here with is an output of what I'm going to call bags, which is going to be a dictionary, is what I'm thinking. And we're going to go through for relationship in relationships, right? And now we need to actually start parsing each individual line or relationship and finding out what's the top level and what are the bottom levels and how are they related. So we've got in each line we have this contain right here. So we're going to split on the contain because every single one has contain. Now, one interesting thing to note is that we have faded blue bags which contain no other bags, which is okay, cool. So they don't contain anything else. Dotted black bags contain no other bags either. So we're going to have to put something in there to account for that as well. So we're going to say that we're going to split on the contains, or contain, yeah. Bright light contain. Okay, so we're going to say that we've got our line, relationship. Actually, let's say parent bag, and we're going to say children is relationship dot split, and we're splitting on that contain, right? And I'm going to use the spaces in there, and now we should end up with a parent and a children. And then we're going to parse out the children, and then we're going to create this bags object with a parent, and then it has the number of children that it's related to. And it's going to have basically a parent bag, and then it will have a list, and within each list it will have a count, and it will have the names of those children bags. So let's do that. We're going to say we're going to say that we've got our what our contains is we're going to split on, I think there's a comma here. So we're going to split on the comma, and then we're going to try and parse this number out, and then the shiny gold bags. So let's start there. So our contains, so our children are actually, let's just print the parent bag here. And we'll say that the children are going to equal the children.split, and we're going to split on a comma. And we're actually going to split on a comma space so that it eliminates that comma space in there as well. Okay. And we're going to print the children. So we're just going to start here, and we're going to parse the bags. Children, I said children. There we go, children. Okay, and we're going to parse the bags. So we're going to say bags is parse bags data right there. And then we'll pass bags into our different parts. That's what I'm assuming. Okay, so let's start by running that. Day 7. If I can hit my keyboard correctly. Okay, so we've got light red bags, perfect, and we've got 1 bright white bag, 2 muted yellow bags. Okay, so we've got this bags with a period, and we also have just bag, and we're probably going to have to remove either the words bag or bags, or we're going to have to add an S on there. We might just remove the S period from there, or well, this one also has an S, that one also has an S. So we might just double check that it ends with an S. And we'll remove any periods, but we'll make sure that the description ends with an S. And that way it will make everything consistent. So that it will have a name. So what we're going to do is we're going to say bags. So we have the children, and now we're going to say we're going to say for child in children, we're going to have a number, and we're going to have a description. So let's split child equals child.split on the space. So that should work just fine. And let's print off the child here. Okay, so now we've got 1 bright white bag. Okay, so next we're going to take the very first one. The very first value is going to be the value for the child. Value is going to be int child, and that's the very first one. And then the description is going to be child, and that's going to be the first through the last values. And we're going to do a space.join on those, okay? And if I did this correctly, this will be almost the exact same, right? So 3 white bags, right? That's what we parsed, 3 white bags, 3 white bags. It looks the exact same. 4 muted yellow bags, 4 muted yellow bags. Okay, so that's exactly what we were expecting. But we now get an invalid literal for an int with base 10 no. And that comes back to this faded blue bags contain no other bags, right? So we need to throw in a check here that says if the child contains no or something like that, we can just skip over it. We might actually just say if children is what does this look like? What does this look like? No other bags. So if children is no other bags, then we're going to say bags parent bag is going to be an empty array, and we're going to continue with an E. Continue with an E. So we're going to continue on to the next parent-child relationship. So if we run this again, yay, we didn't get an error. Okay, so we just corrected the error. Okay, so let's get rid of all these print statements here. We know that we're getting the correct values and descriptions. And now we're going to say that our bags here, and we're going to have parent bag is going to equal that. Actually, let's come up first here and do this, and then we can get rid of that line, right? Yay. Okay. So if it has no other bags, we just continue, and now we can add to that particular parent bag. We can say bags parent bag dot append, right? Because we're appending to this particular list, right? We're going to append, and what we're going to append is actually a dictionary where we have value, and we have do we want value? No, let's say count, because we're counting the bags. So we're going to have a count of bags that are going to be the val, because I used value. And we're going to have the name, or maybe we should have the color. We'll call it color here because it did specify a color. And we're going to say description. Okay, and I'm going to rename these because I want to keep it consistent. Count, and we're going to have color. Okay. Okay, so we're going to print off the bags, and we'll return the bags, and we'll see what this looks like. Bam. Okay, so we have light red bags can contain one bright white bag. Okay. Now, one issue here is that we still have this bags, and we have bag, right? We could just get rid of that final one, which we might do is we might just get rid of the final word in each of those. So let's say that our color is going to be that, which means we end up with bright white, dark orange bags contain that, which, okay, so now we're going to have to change the parent, right? Parent is going to have to be parent bag dot split, and we're going to have to go through all the way up to the last value, right? And we're going to say, okay, now this is because we've got this muted yellow. Now all the children are correct, but the top level is light red bags. Well, now we've got to get rid of the word bags so that we can look up the children into the parent values to see if they've got if we've got some recursion going on there. Okay, so now if we rerun this, we get light red, right? Turns into one bright white and two muted yellow, right? And that's the count, and that is the color right there. Okay. So let's get rid of that. We've got our bags, so now we can pass this into part one. Okay, so now the question is, what does part one actually do? What is the question for part one? Now that we've parsed the bags and everything, we get the value, we get or the count, right? And the color, and we have the color contains the count and the color. What is the question? And the question is, you have a shiny gold bag, and we want to see how many different bag colors would be valid for the outermost bag. Okay, so we need to find out if if a colored bag can contain the shiny gold bag. Okay, so that's what we're going to do is we're going to essentially create a function called can_contain. That's what we're going to call it. Def can_contain, and we're going to call this a bag. So we're going to look for a particular bag, and we're going to look at the bags overall. So we're going to be looking for a particular bag within the bags. Okay, so if we have shiny gold in the okay, so now we've got children, or let's say child color. So if shiny gold in child color for child in bag, we have bags, bag, right? Because this is going to be a string here, and this is going to be a dict with the string moving to a list. Okay. Okay. So if shiny gold is in the child color for child in bags, so we're looking in this particular bag. So in all the bags, we're looking in this particular bag by name, and we want to see if shiny gold is the color of any of the bags in that bag. Then we can then we can return true, right? And that will give us the results that we're looking for there. However, if we want to go into a next bag, is what I'm going to call it, for next bag in content, no, let's continue with child color. Let's just copy this. So basically what we're going to do is we say, okay, if shiny gold is in there, then we return true. If that's not the case, though, we want to go through every single bag in that bags and check again if that can contain the particular bag. So we're going to go through each of these colors. So next bag is going to be, we're going to be looking at bags again. Okay, so if this next bag can contain the shiny gold, right? Basically here, right? If the next bag can contain that, then we'll return true here. Otherwise, we end up returning false down here. So we've essentially done a recursion that looks back through all the children bags, and we'll iterate through all the children bags and find out if they can contain shiny gold. Okay, so now we need to go through and get a total, and we're going to call the total 0. Of course, we're going to initiate it with 0, and because we're counting, so we're going to add to that, and we're going to say for bag in bags.keys. So we're going to iterate through all the bags by name, and we're going to say if can contain the bags, then we say total plus equals 1, and then we return the total, just like that. So we did a lot of work up front to get all the parsing correct so that we can check whether or not shiny gold can be contained within the bag, and then we count. We just count the number of bags that can contain the shiny gold bag. There we go. Okay, so let's try this. List object has no attribute keys. Oh, because I'm passing in data when I should be passing in bags. Let's try this instead. 4. Okay, so 4 is the answer there. Let's double check if that, okay, yes, so that is the correct answer. So let's get the puzzle input, and wow, that is right. And let's throw that into the input.txt, and we'll try this again. 126. So we'll test and see if 126 is the correct answer. And it is! Yay! Okay, so 126 is the correct answer. We get a gold star for part 1, and we'll continue on to part 2. I guess you get a silver star for part 1, and a gold star for part 2? Huh. Okay, so it's getting pretty expensive to fly these days, not because of the tickets. Okay, consider, again, your shiny gold bag, and the rules from the example above contain 0 other bags. Dotted black bags contain 0 other bags, contain 11 other bags. 5 faded blue bags and 6 dotted black bags. Dark olive bags contain 7 other bags, etc. So a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags and the 11 bags within each of those. So in this example, a single shiny gold bag must contain 126 other bags. So 126 is the number that we're looking for. Oddly enough, 126 was also the answer to our last question. Coincidence? Probably. Okay. So let's re-input. Let's replace our input data. Shiny gold bags contain 2 dark red bags, and we're essentially going to say, okay, we've got 2 dark red, and we're going to look at the dark red contains dark orange can contain dark yellow, and dark yellow contains 2 dark green, and we want to count up essentially the number of bags that each of these can contain. So we start off with the shiny gold, and then we're going to iterate through and find out how many bags essentially we can fit into 1 shiny gold bag. It's like what's the movie that I'm thinking about where the lady pulls out all of the stuff out of the bag? I don't know. Mary Poppins. There we go. I knew it would come to me. Okay, so we've got part 2. We've got our parsed bags now, and we have the count, which is what we wanted. What we needed was the count here, and essentially we'll start off with contained bag is going to be bags, and that's going to be the shiny gold bags, and we're going to say that our total is 0, right? And then we're going to add up anything that can fit into the shiny gold bags, and we're going to say for sub bag, actually let's say for child in contained, and we're just going to call this parent, right? Parent. Let's stick with the parent-child relationship. For child and parent, we're going to say that our total is going to plus equal our sub bag count times, and this is where we're going to do recursion again, where we have our where we're calling back this particular function again, and we're going to use the part 2 function again with sub bag, and we're going to use that color. Okay, so we're going to go through each of the sub bags, and we're going to count up the total number of bags that are possible in there. Oh, sorry, I did say sub bag, didn't I? Child. There we go. So the child bags. Whoops. Yay, bring that back. Okay. So we've got each of these different child in children. Whoa, where am I? Okay. Child in parent. We've got the total for each child. So we're going to take the child times times this part right here. Now, what's going to be interesting is that if we multiply this and it has no other bags, this part is actually going to give us a 0, right? We're going to take the child count and it has no other bags as part of the child values, and so it's just going to return 0 for that particular value. So we're actually going to add 1 here because we both want, because we need to be able to count those child bags. Essentially, we need to be able to continue to count this bag, even if we don't have any child bags. Okay, let's test this out. String indices must be integers. Yay. Bags. Shiny gold. Okay, now I'm confused because we made it to part 2. Part 2. What did we do wrong? What did I do wrong? Because this, I really would think that this would work right here, is that we've got our data, we're passing in the bags. We, string indices must be integers. We have shiny gold right there. Hmm. Let's just test some things out. I wonder if I'm doing something as part of the recursion that where I should parse the bags sooner. Not enough values to unpack. Dark violet bags contain no other bags, and I get this D. What is this D? We just have a single line. Relationships, parse bags. Oh, I'm passing in child by color, so of course it can't parse that. So we really do need to pass in bags here, right? So now we're passing in bags with the child color. List indices must be integers or slices. Bags. We're passing in bags, which is this. Why is this a list? Oh, because I forgot to input bags right there. Okay, this makes, well, we're getting different data now, which is good. Okay. Print bags. So our bags are going to be this. Where else are we printing? We're printing the relationship. Let's not print the relationship. Okay. Plus for none type and int. So we're adding together a none value, child count. Oh, okay, so this parent's bag, so if it contains no other bags, then, oh, if it contains no other bags, we need to actually account for that count, right? So we're going to have a count of 0. So bags, oh wait, actually, let's keep the continuant here, but bags, parent, bag, oh, okay, so we're going to have color is none. Yay, okay, maximum recursion depth exceeded. Okay, so now we need to take into consideration that we might have this, that we have this none value, and we need to put that into this. So if parent is none, so if parent is none, return 0, and we're going to call this one with shiny gold. There. So if parent is none, we return 0. Yay, okay. Part 2, child color plus 1. So color is going to be part 2, bags. Yay, we've got to return a total. Okay, 126. There we go. That's the answer that we expected. I wonder how much of this was actually due to the fact that I was returning a none value and wasn't accounting for that. But now we have something that actually works. So we have a default parent value. We're not going to allow a default parent parent value here. If the parent is none, then we return 0. So if the color is none, we know that it has 0 bags, and we'll return a 0. We'll return 0 to it. So this one bag can contain 0 other bags. So we'll return 0. Otherwise, our parent, we're going to rename that as bags parent, and that will pull in, and that will essentially go through all the children values of that parent and rerun this. Okay, there we go. So let's test this out with the real data here and see if we get the correct answer. Yay, we got the correct answer. That's exciting. Okay, so 220,000 different ways to get this this answer correct. Oh, there we go. 220,000 different ways. Okay, so let's go through and let's clean up this code just a little bit more, because obviously we have a lot of print statements that we don't need. We've got these, got this, that looks good. This looks good. Yay, recursion. We can get rid of that comment. That's not needed. We can, bags like this. This is good. Children is children.splits for child and children. Makes sense. Okay. I don't really see a way of really cleaning it up, except for maybe adding some extra documentation in here, but this was just to help me keep in mind, okay, we're passing in bags, which is a dictionary that has a string that connects to lists, right? And that's kind of how I was thinking about it. There we go. Okay, so I think that's actually it. So with that, that was day 7. Thank you very much. If you stuck around for all of that, good job. This was one of the harder pieces, one of the harder days in my mind, just because of all the recursion and what was going on. So if you have any questions or comments, throw those below the video in the comments section. Don't forget to like, share, subscribe. All the subscriptions help to the channel and encourage me to keep going. So please continue to do that. If you have any questions, let me know. Otherwise, I'll just see you in the next video on to day 8.